Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil Hakim bin Ismail and I will explain about our final year project. The title is our project is a comparative study on the consolidation test of traditional and non-traditional stabilized peat. Okay, for the introduction, peat is defined as a brown deposit resembling soil formed by the partial decomposition of vegetable matter in the wet acidic condition. Peat are highly organic soil, diverse mixture, and undergo anaerobic condition at moderate and low temperature are the sum of the physical properties of peat. The peat are unsuitable for the engineering works or project because this soil is inefficient to resist load and low initial strength. Peat also has a high settlement. The stabilizer can be used to overcome the settlement problem of peat. For the aim and objective, the study aims to analyze a comparative on the consolidation test of traditional and non-traditional stabilized peat using Plexis 2D. The objective is to identify the settlement of original peat and to observe the effect of the different types of stabilizer to the settlement of peat. Okay, for the scope, the research focus on the type of stabilizer used in the experiments. The data and parameter of peat and stabilizer will be collected by searching journal and previous study. The stabilizer used are cement and polymer. The experiment will be conducted as sample of PT, PTP and PTC. The experiment will be done by using Plexis 2D.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid Nifzal bin Abdul Halim and I will explain about the objective of our study. The objective of this study that our group had done is to identify the settlement of original peat. Second, to observe the effect of different types of stabilizer to the settlement of property of peat.
Okay, next is for the general properties of peat. First, moisture content. In Malaysia, moisture content of peat are ranged between 200 and 2200%. However, there are some tests conducted at peat located in Johor. Then the results show the water content of peat is ranged between 230 to 500%. Other than that research, there are research that has conducted at the West Malaysia, and the results show the properties of peat in Malaysia was similar, and some of properties are not same with the other research. This shows that Malaysian peat soil varies with different geographic location even though the natural water content may be similar. This is due to the influence of different agriculture history of the area and rainfall intensity. Okay, second is bud density. Bud density of peat is low compared to another soil. The average bud density of peat is around 9.81 kN per meter square. Bud density of unit of peat in Malaysia found range from 8.3 to 11.3 kN per meter square. The unit weight of bud density of peat will be affected by the water content of peat. If the water content above 500%, the unit weight range from 2 to 13 kN per meter square. Okay, third is liquid limit. Difference in liquid limit of peat depend on the type of plant detritus, degree of humidification and clay content. As for the liquid limit of peat in Malaysia, range from 190 to 550%. Okay, next is for the peat stabilization. Stabilization is process to stabilize or make something physically secure. Peat stabilization is a process to make alteration to the negative geotechnical become better. By this process, either using a traditional or non-traditional stabilizer. This process will lower the peat moisture content, increase the shear strength, and lower the compressibility. The result after this process will produce more suitable peat that can be used in construction work. Physical or chemical resection that will maintain the original properties of it or improvise the stability of curtain soil to make it more durable.
Okay, next I will explain about the methodology of our test. So what is Plexis? Plexis is a finite element program which is designed primarily for deformation and stability analysis, which focus mainly in geotechnical engineering projects. Then, it also will provide a detailed presentation of computational finding, research, and simple graphical input that will allow for speedy development of finite element models. So this is the flowchart of our group. We will start the process with design the sample, then we will insert the load in the design, insert material in the design, then we will generate water pressure and generate initial stress to identify its initial condition. Then we will plot in the graph as our result and we calculate the data. So for the first step, geometry model. Creation of geometry model is by using Plexis 2D software. Then geometry model consists of inputs of lines and points. So this is the design of the model that our group had made. The height and width is 1 meter. The material consists of original peat or stabilized peat, which is using the traditional stabilizer or non-traditional. At the above is the load that we will put the sample. After we had designed the model, we will generate mesh the model. So after we had generate mesh the model, we will obtain finite element model. So this is the finite element model of our group. This unstructured mesh is not formed by regular patterns. Performance of this regular mesh usually better than regular shape and structured mesh. This process itself will transform the input data such as boundary condition and material set to the finite element. Thirdly, we will insert the load. Before that, we have to identify the boundary condition. Boundary condition need to identify to avoid the undetermined displacement of geometry. The two sides of the model are labeled as vertical fit cities, and for the bottom, vertical and horizontal. Two vertical parallel lines will be assigned to a roller support. So this is the boundary condition for our group. Vertical on the left, vertical on the right, and vertical and horizontal at the bottom. Then we will apply load to our model. Load that are assigned to the geometry model will be used distributed load. The load will be assigned by clicking this icon in the interface and by clicking point 3 to point 2. The load that will be applied are 5 kN, 10 kN, 20 kN, 40, 80, 160, and 320 kN. Then, insert material will be the next step. Needed inputs are designed in such a way that is logically viable to complete the task. Study that produce the parameter will be applied. We will find previous study about the parameters about original peat, stabilized peat, either cement or polymer to be insert in the material, to be insert as the material. Then to put the material, we will click this icon in the interface to enter the value that we get from the previous study. So this is the interface windows that we will choose to determine our material. Select identification to make a name for study. As an example, Peat original. So this is one of the example of our original sample. This data we obtained from previous study, and some of it we use it from the global, which is already in the Plexis 2D. So this is the list of parameter that we had been used for original peat, peat and cement, peat and polymer. When the values are entered in the correct place, apply it to the box or sample to activate and replace it into the design container, so the material will be activated.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fazli bin Manizam, and now I would like to explain the initial condition. The initial condition is the part or step after apply material in design. Generate water pressure. The initial condition is water pressure of the sample involves are defined as 10 km meter unit wide for all sample. The general water pressure, that's a sample 1 4.1 is the sample of original peat, and 4.11 is the stabilized and cement, and 4.12 is pressure of polymer. After you apply the load, analyze and update, you can get this result. After that, you turn the initial to generate internal stress. If you click the button icon to change the generate initial stress, the weight of soil m weight equal to 1 to all sample. This sample of same load and stress. After the update, we will get the result. The critical part of this, we can see the polymer have many initial stress than the stress for peat original. This show the result of initial stress. Okay, in part calculation, we want to run the process, right? First step, we must rename the process. For example, I rename as a starting load, and the type of process is plastic analysis to section the type of spot. After that, we define the load and change the load at Y and X for the top of sample. For example, in this sample, I will change -5 for Y and -5 for X. After we change it, we can run for starting sample. Uh, okay. After starting sample done, this we can continue to consolidation process. For consolidation test, it's same step, but we must change at the last step. We must put at duration of the sample. For example, this situation, the sample will take 1 day for running. We'll apply and run all at the same time. This show load and calculation type. For example, starting load, load 5, load 10, and until 320. First starting load, only plastic analysis. Other than that is consolidation analysis. First, to plotting the graph, we click the tools bar and the program center. After that, we find the file that we have done the sample and open it. After open it, for this project, I choose y-axis for displacement and x-axis is time and plotting at point A. After that, click OK and we can get the result. After we get the result, we will compare for original, stabilizer cement and stabilizer polymer. This it can show the polymer very high. The relationship settlement again time of the samples. After get the graph and collect the data, we also can get other data. For example, total displacement. Total displacement that show we can choose for this project. For my project, I will choose total displacement. They are the major point that we have to observe. This show the settlement displacement, total displacement is very high is cement. After that, the polymer, and lastly the peat, the original.
As a conclusion, by the result, original peat is the highest value of settlement among all samples. This is because the sample of original do not have any additive or stabilizer in it to stabilize its property to make it stronger and less void. And the most low settlement shown by the result are non-traditional stabilizer, which is polymer. Polymer has filling up the void which before it is filled with air and water. The objective of the project also fulfilled as the settlement of original peat without any stabilizer have been identified. In addition, we also can identify the better stabilizer used in this project, which is polymer. For the recommendation, a new user of Plexis 2D can training before using the software. Parameter used for Plexis 2D must to be accurate for the better result.